Elixir guides. Supervisor and Application. So far, our application has a registry that may monitor dozens, if not hundreds, of buckets. While we think our implementation so far is quite good, no software is bug-free, and failures are definitely going to happen. When things fail, your first reaction may be, let's rescue those errors. But in Elixir, we avoid the defensive programming habit of rescuing exceptions. Instead, we say, let it crash. If there is a bug that leads our registry to crash, we have nothing to worry about because we are going to set up a supervisor that will start a fresh copy of the registry. In this chapter, we're going to learn about supervisors and also about applications. We're going to create not one, but two supervisors and use them to supervise our processes. Our first supervisor. Creating a supervisor is not much different from creating a gen server. We're going to define a module named KV supervisor, which will use the supervisor behavior inside lib kv supervisor.ex file. So def module kv supervisor, use supervisor, we have a start link and a init. Our supervisor has a single child so far, KV registry. After we defined a list of children, we call supervisor init2, passing the children and the supervision strategy. The supervision strategy dictates what happens when one of the children crashes. 1 for 1 means that if a child dies, it will be the only one restarted. Since we have only one child now, that's all we need. The supervisor behavior supports many different strategies, which we will discuss in this chapter. Once the supervisor starts, it will traverse the list of children and invoke the child spec1 function on each module. The child spec1 function returns the child specification, which describes how to start the process. If the process is a worker or a supervisor, if the process is temporary, transient, or permanent, and so on. The child spec function is automatically defined when we use agent, use gen server, use supervisor, etc. Let's give it a try in the terminal with an IEX X mix. So KV registry child spec. Get this. We will learn those details as we move forward in this guide. If you'd rather peek ahead, check out the supervisor docs. After the supervisor retrieves all child specifications, it proceeds to start its children one by one, in the order they were defined, using the information in the start key in the child specification. For our current specification, it will call our kv registry.startLink. In the previous chapter, we have used start supervised to start the registry during our tests. Internally, the start supervised function starts the registry under a supervisor defined by the XUnit framework. By defining our own supervisor, we provide more structure on how we initialize, shut down, and supervise registries in your applications, aligning our production code and tests best practices. So far, StartLink 1 has always received an empty list of options. It's time to change that. Naming processes. While our application will have many buckets, it will only have a single registry. So instead of always passing the registry PID around, we can give the registry a name and always reference it by its name. Also, remember buckets were started dynamically based on user input, and that meant we should not use atom names for managing our buckets. But the registry is in the opposite situation. We want to start a single registry, preferably under a supervisor, when our application boots. So let's do that. Let's slightly change our children definition to be a list of tuples instead of a list of atoms. So we name them. The difference now is that instead of calling KV registry start link, the supervisor will call KV registry start link name KV registry. If you revisit KV registry start link 1 implementation, you will remember it passes the options to GenServer, which in turn will register the process with a given name. Let's give this a try in IEX. So we KV supervisor start link, KV registry create, KV registry shopping, and then lookup. When we start the supervisor, the registry was automatically started with the given name, allowing us to create buckets without the need to manually start it. In practice, we rarely start the application supervisor manually. Instead, it is started as part of the application callback. Understanding applications. We've been working inside an application this entire time. Every time we changed a file and ran mix compile, we could see a generated KV app message in the compilation output. We can find the generated .app file at _build dev lib kv ebin kv.app. Let's have a look at its contents. This file contains Erlang terms, written using Erlang syntax. Even though we are not familiar with Erlang, it's easy to guess this file holds our application definition. It contains our application version, all the modules defined by it, as well as a list of applications we depend on, like Erlang's kernel, Elixir itself, and Logger, which is specified in the extra applications list in mix.exs. It would be pretty boring to update this file manually every time we add a new module to our application. That's why Mix generates and maintains it for us. We can also configure the generated .app file by customizing the values returned by the application 0 inside our mix.exs project file. We are going to do our first customization soon. Starting applications. When we define an .app file, which is the application specification, we are able to start and stop the application as a whole. We haven't worried about this so far for 2 reasons. 1, Mix automatically starts our current application for us, and 2, even if Mix didn't start our application for us, our application does not yet do anything when it starts. In any case, let's see how Mix starts the application for us. Let's start a project console with IEX and try application.start kv. Already started. Oops, it's already started. Mix normally starts the whole hierarchy of applications defined in our project's mix.exs file, and it does the same for all dependencies if they depend on other applications. We can pass an option to Mix to ask it to not start our application. Let's give that a try by IEX run no start. It's handy. We can stop our KV application as well as a logger application, which is started by default with Elixir. And let's try to start our application again. Error, not started, logger. Now we get an error because an application that KV depends on, logger in this case, isn't started. We need to either start each application manually in the correct order or call application ensure all started as follows. Nothing really exciting happens, but it shows how we can control our application. When you run IEX, it is equivalent to running IEX mix run. IEX mix, it is equivalent to calling IEX mix run. So whenever you need to pass more options to mix when starting IEX, you pass them in after run. The application callback. Since we spent all this time talking about how applications are started, stopped, there must be something useful when the application starts. And indeed, there is. We can specify an application callback function. This function will be invoked when the application starts. The function must return a result of OK PID, where PID is the process identifier of a supervisor process. We can configure the application callback in 2 steps. First, open up the mix.exs file and change def application to the following: extra applications, logger, mod, kv, empty list. The mod option specifies the application callback module, followed by the arguments to be passed on application start. The application callback module can be any module that implements the application behavior. Now that we have specified kv as the module callback, we need to change the kv module defined in libkv.ex. So use application. When we use application, we need to define a couple functions similar to when we used supervisor or gen server. This time, we only need to define a start_to function. If we wanted to specify custom behavior on application stop, we could define a stop_1 function. Let's start our project console once again with IEX mix. We will see a process named kv registry is already running. How do we know this is working? After all, we are creating the bucket and then looking it up. Of course, it should work, right? Well, remember that kv registry create2 uses genserver cast2 and therefore will return OK regardless of whether the message finds its target or not. At that point, we don't know whether the supervisor and server are up and if the bucket was created. However, kv registry lookup2 uses genserver call3 and will block and wait for a response from the server. We do get a positive response, so we know all is up and running. For an experiment, try re-implementing kv registry create2 and use genserver to use genserver.call3 instead, and momentarily disable the application callback. Run the above code on the console again, and you will see the creation step fails straight away. Projects or applications. Mix makes a distinction between projects and applications. Based on the contents of our mix.exs file, we would say we have a mix project that defines the kv application. As we will see in later chapters, there are projects that don't define any application. When we say project, you should think about Mix. Mix is the tool that manages your project. It knows how to compile your project, test your project, and more. It also knows how to compile and start the application relevant to your project. When we talk about applications, we talk about OTP. Applications are the entities that are started and stopped as a whole by the runtime. We can learn more about applications and how they relate to booting and shutting down of your system as a whole in the docs for application module. Next, let's learn about one special type of supervisor that is designed to start and shut down children dynamically, called dynamic supervisors. Let's check that out next. All right, be right back.